Good morning. This is Emerson with ATAGO, and today we'll be looking at metalworking again, but this time we'll be doing viscosity. So in the world of metalworking, we are used to seeing bricks as one of the parameters for quality control. We're also used to seeing pH and conductivity. Those are the three main quality control aspects of metalworking for cutting, for cutting fluid. So today we'll be looking at a different aspect, not the refractometer or the pH meter side of things, but the viscosity. This is not sure if it's not as common. I know it's mostly used in other parts of metalworking that's not cutting, so it's not on the CNC machine as much as it is on other areas, or maybe just refractometers overtake the CNC part of metalworking and viscosity is not heard as much. But anyways, today we're going to focus on viscosity, and I wanted to give you like a quick summary of things. In the metalworking fluid types, you have straight oils, you have soluble oils, semi-synthetic and synthetic. We're not going to go in detail with these. I just wanted to show you the different types of oils, because each one has an advantage or disadvantage, and sometimes they're used in different areas because of those advantages. But I just want to state those here. For metalworking, the four main categories for metalworking are cutting, which is milling, turning, grinding, drilling. It's taking a piece of metal and you're cutting it. You're taking away metal in different ways, where you're cutting it or milling it or grinding it, and you're making a shape of something else that is not. That's cutting. Forming is changing the shape of the metal itself, not necessarily adding metal to it or taking away metal. Like in cutting, we're taking away, we're grinding off, we're drilling off, we're milling off, right? In forming, we're just changing the shape of the metal. In casting, we're also kind of changing the shape of the metal, but in a different way. You basically you have like a big mass of molten metal or metal, and then you're making it into smaller pieces. And then joining metal, which has to do with welding or soldering or riveting. Welding can be on a mass scale. Soldering is sometimes, usually, on a smaller scale. And a riveting could be both, but medium to large scale as well. So that's joining. So like I said before, in metalworking, we have bricks and pH and conductivity. This image here, I put it because it's what most people associate with metalworking, but this picture only represents one part of metalworking, which is the cutting part. There's four. So the types of fluids that are used, these are not all, but just are the ones that we're gonna see today. Cutting, we've already seen when we were presenting the past metalworking classes for pH or for inline refractometers or for handhelds. So cutting, the controlling of concentration of the cutting fluid, we've seen a lot. Today we're going to focus more on forming, maybe a little bit of casting, but forming. That's where you have the drying and the rolling that we're going to see in a bit. Okay. So like I said, for cutting, whether it be milling, turning, grinding, or drilling, we're used to seeing bricks, pH, conductivity. There is viscosity. There is viscosity in the R&D area. There is some viscosity in the manufacturing side, especially if they want to They need to make high precision parts. They need to be very careful with viscosity. The thing with viscosity is though it's mostly up up until before ATAGO came into the viscosity world. Viscosity was mostly a benchtop kind of thing. So it was benchtop. It was in the lab. So it was away from, or mostly away from the production floor. ATAGO, bringing in one of the first couple of handheld viscometers or portable viscometers, are bringing the viscometer into the production area. So it's bringing the viscometer where you could be using the metalworking fluids. So ATAGO is changing the market in that way. It's changing the use of viscosity in that way. So even though it's being used in a certain way, because we have a portable one, the industry is starting to adapt a little. Oh, we have a portable. We can bring this into the production floor. So yeah, so that's metal working, as in cutting, milling, turning, grinding, drilling. The ones we're going to focus on is forming, whether it's forging or rolling or drying or molding or pressing. We're not going to see forging too much, or molding maybe just a bit. Rolling and drying are very similar in a way, totally different, very similar. Rolling is when you have a big piece of metal, a bigger piece of metal, and you have two rollers. You have two huge metal drums, if you could call it, and you will squeeze this piece of metal between those two drums, and on the other side it comes out in a different shape, where it be wider, well, not wider, it usually is thinner. That's how you would make like sheets of metal. So you're basically pressing the metal and changing the shape, making it thinner. You can do this by cold pressing or by heating up the metal. But either way, you need lubrication between the rollers and the metal, and all the way where the sheet is formed, so that it's more efficient. It's lowering drag. It's lowering static. It's decreasing the heat that it's being made from the compression or from the rolling. So here you have a very generic image of a tank with clean oil, and the oil is then sprayed onto the metal part, and then it's rolled. This concentration can be measured or controlled via bricks, but also the viscosity is very important, because if it's too viscous, it will affect the surface and the quality of the rolling. If it's too low for viscosity, it will also affect it in different ways. Drying is kind of similar to this. Drying is where you have a bigger piece of metal, and the difference is that when you're rolling, you're pushing this metal into this area here. Drying is that you're pulling the metal from this side, and you're pulling the metal from this side, and as you go pull, you're stretching it. Think of it like a rubber band in a way, where you have one piece here and you're stretching it over here. Something similar happens with metal, so it stretches out. So drying is most commonly used in making wires, making whether it be electric wires or different types of wires. So you also need lubricants when you're rolling metal. So the measuring concentration and measuring viscosity of that lubricant is very important. Another one that we're going to see right now is the pressing. I don't have a good picture of pressing. But pressing is you basically have a chunk of metal, and you have a mold, and then you're pressing this piece of metal into that mold, and then you're coming up with shapes like this. So if you take off these tops, let's see if I can do it here. Yeah. So if you take off these tops, basically, that's how you do the cans. You're pressing the metal into a shape, and it comes up this way. That's pressing. So in order for you to have this smooth wall, both outside here and on the inside, you need to control the viscosity of the lubricant. If viscosity is different, then your can might come out misshaped or torn, like not even, not have even walls. Okay, so that's just a very quick introduction of different places that can measure. You can measure viscosity of metalworking. If you go to the Quicker Heaton website and you go to product lines of the industrial side, you're gonna see a full list of different products that they have. Of course, these products you can be using pH, refractometers, viscometers. But for example, here the can making lubricant is specifically for making cans, which is this one. And then we have the metal, where is it? The metal rolling, it's for this one. Okay, so here you have, and then you have surface treatments and you have cleaners. These are cleaners is after the metal is, you're finished working with the metal, whether it be a sheet of metal or a piece of metal from a CNC machine. It has lubricant on it. It have pieces of metal. So cleaners, you tend to rinse off the oil. So you can use refractometers here. Surface finishing or surface treatment, both of these. It's like the coating that you put on the metal once you're finished with it. Normally, you could use refractometers or viscometers as well for surface treatment because of the surface tension of the liquid, the treatment. Yeah, so they have a whole list of different products that they offer, and ATAGO can help in the quality control of those, whether it be bricks, conductivity, pH, or in today's case, we're talking about viscosity. Any questions so far? No. Okay. If you have questions, just type it into the chat. And if not, then we will post our email right now and you can email us. I want to talk to you about the Oswald and the, I'm not sure how to pronounce that, Ubellard viscometer. So this is one of the most popular and cheaper viscometers in the metal working industry. It measures kinematic viscosity. So there are different viscosities out there, types of viscosity. This one is designed to measure kinematic. This one is not an ATAGO viscometer. The one to the left, the Visco, is the ATAGO viscometer. Visco measures dynamic viscosity. Okay, but you can also measure kinematic viscosity, just like this one. Okay, except it's through a different method. This is through gravity, and this is through rotation. And so kinematic viscosity, which is what this measures and this measures, kinematic viscosity is basically equal to dynamic viscosity, which is Cp. Dynamic viscosity is like the base viscosity that all spindle types measure, divided by density. So kinematic equals dynamic divided by density. That's how you get kinematic. So if this instrument is already reading dynamic, all you need to do is input density. Okay, and we have that option. So our Visco, whether it be a Visco BL or this Visco, has the option where you can input the density of the liquid to calculate, well, not to calculate, you input the density of the liquid so that when he is spinning and he's measuring dynamic viscosity, he outputs kinematic viscosity. So basically, the Visco will output kinematic viscosity just like this gravity one. Okay, and if for some reason the reading is slightly off, because this is through gravity and this is through spinning, rotational spindles, maybe there's a little difference, then you can use the user scale, where you can bring the measurement of this closer to this. Okay? And this is how you can use the Visco for metalworking. And most lubricants are measured at 40 Celsius, not all, but most lubricants are measured at 40 Celsius. So using the Visco with the temperature controller is also recommended. Okay. For these guys, for rolling and for pressing, normally viscosity is very low. So you would be looking for the Visco with the ULA, the ultra low viscosity adapter, and the temperature controller. So you're looking at very low viscosities. If it's other types of lubricants, maybe you're gonna need, without the ULA spindle adapter. But if you buy the Visco and temperature controller complete, you're gonna have all the parts you need to measure all the range of viscosity of lubricants from high viscosity to very, very low viscosity. Any questions? Okay, that was it. That's all for today. Thank you very much for joining us. If you have any questions, please email us and we're gonna type it in right now. Thank you very much. Have a good day.